Hi, class. Welcome. It's Dr. Lindner. What we're going to be discussing in this video is going to be bone and bone physiology, and I'll have this broken up into different segments. So, when we talk about bone, bone is an organ, and it's made up of several different tissues: bone, cartilage, dense connective tissue, adipose or fat, and neural tissue. And they all kind of work together. The entire framework of bones and their cartilage make up the skeletal system. So, again, to review, the skeletal system is made up of all the bones of the skeleton, right? The axial skeleton, the appendicular skeleton, all the cartilage, the fibrocartilage, the elastic cartilage, and the hyaline cartilage, all the ligaments and connective tissues combined. Bone is specialized type of connective tissue, and it has living cells that are held in place by an intercellular matrix of collagen fibers that are embedded within calcium salts. So I think of the collagen fibers as like steel beams that are going to hold up a building, and then the calcium salts will be all the cement that's surrounding all of the collagen fibers, making it very strong and very stable, holding it in place. Okay, and this is typically how you end up seeing a lot of buildings built. You've got the steel, and then you have all concrete around it to help reinforce it. And collagen probably makes up at least 1/3 of bone. Somewhere between 30 and 30% of bone is collagen, which is protein. So this helps to reinforce several factors. Number one, you need to have complete protein in your diet. But again, it's not what you eat, right? It's not you are what you eat, it's you are what you can absorb, which means you need really good, healthy digestive enzymes. We need to make sure that we can break down the protein. So we need that low pH, somewhere around 2.3. And what that low pH does is that ensures that you have healthy hydrochloric acid so that we can convert pepsinogen in the stomach into pepsin. Pepsin is the digestive enzyme that's needed to break down the protein. HCl knocks off the ogen and gives us pepsin. So think of what happens if people are using antacids or they're drinking high pH water. What does that do to the digestive enzymes and their ability to function in the stomach? It really decreases the or impairs the function of it. So you need good protein, good digestive enzymes, healthy pH, good pepsin to break down the proteins. The proteins can be utilized to make collagen. And we also need vitamin C. Vitamin C is a precursor to collagen formation. So there's lots going on here. And of course, you need calcium. You need good calcium in your diet. And we need vitamin D to help absorb the calcium. Again, it's not what you eat, it's what we can absorb and assimilate. So we need vitamin D to help absorb the calcium. And then we need vitamin K to drive that calcium from the blood that we absorbed the calcium into the bone. So lots of different things going on here. The skeletal system provides support for us, and it protects the internal organs. Like, the brain is protected by the skull, right? That the skull ends up being the helmet that protects the brain. We have the sternum. We have the ribs that help to protect the heart and the lungs, etc. So we have the pelvis that protects the digestive organs and reproductive organs. So the skeletal system is very, very important for protection of the internal organs, and they assist in movement and locomotion. Why? Because muscles attach to bones by way of tendons. When muscles produce their contractile force, they transmit the contractile force through the tissue of the muscle. The tendons are somewhat inelastic. And when that inelastic tension is transmitted from the muscles to the tendons to the periosteum of the bone moves. Bone is involved with mineral balance, mineral homeostasis. It stores and releases calcium and can store and release phosphorus. This is why you want to be careful with consuming foods that have, or especially drinks, that have phosphoric acid. If you look at many of the sodas, like Coke and Pepsi and 7-Up, they all have phosphoric acid, which can destroy the phosphorus in the bones. You have to be careful. In fact, if you put bone in any type of acid, it pulls out the calcium. So if you have this beaker here and we put a bone inside, and in the bone is calcium, we know that we got calcium in the bone, and it's sitting in some sort of acidic solvent, whether it's acid, whether it's soda, something, or vinegar, something that's very, very acidic, the body will find a way, or this will find a way to pull the calcium out, because calcium is a buffer, and it'll change this acidic environment into a more alkaline or basic environment. So if you dipped a dipstick into this acid, let's say on the first day, and the pH was 2.5, and you put bones in there, the calcium would be extracted and pulled out from the bone. And a few days later, you may check the pH and it'll say 5.0. It's starting to rise because of the calcium. Okay. Another function of bone is hemopoiesis. Hemopoiesis means blood cell production. So there's the ability to produce red blood cells and white blood cells in bone. And the body can store triglycerides in the adipocytes, or the fat cells of bone. We just call that yellow marrow. And if there is the demand, the innate intelligence can convert yellow marrow into red marrow if the body needs to produce more red blood cells. Okay, good place to take a break. And when we come back, we'll talk about different classifications of bones.